This is mathheals.com, where you can find more links to math and computer science YouTube videos. And let's take a look at arc length and curvature. Now, arc length of a space curve, if C is a smooth curve given by R of t is equal to x of ti plus y of tj plus z of tk on an interval a to b, then the arc length of C on the interval is given by this formula. S is equal to the integral from a to b of the square root of x prime squared plus y prime squared plus z prime squared with respect to t. Or it's equal the integral from a to b of the magnitude of r prime with respect to t. So let's look at our first example. And we got r is equal to 7 ti minus 4 tj. And 0 to 5. And instructions say, sketch the plane curve and find its length over the given interval. I was hoping to have the magnifier figured out so I could show this. I know this isn't hardly viewable at all on YouTube. Eventually I'll figure out the magnifier. Works fine at work, but I couldn't get it to work right here. But what I'm choosing is window, 2 dimensions. And then I'm choosing equation and parametric. And for f of t, we're going to put in 7t. And then for g of t, I'll put in negative 4t. 7t is what's before I, and the negative 4t is what's before j. Now for our low t and high t, I'll put in negative 1 for low t. High t, 2, I guess. I don't know. And I'll click OK. And it's a line. And that's no surprise there. Okay. Now it's a sketch, and now we want to find its length over the given interval. Well, to use this formula, either one, we have to find r prime. So let's find derivative of r. Well, 7t becomes 7, so we got 7i minus, then derivative of 4t becomes the 4. So we got minus 4j. Now let's go ahead and find the magnitude of r prime. And that's going to equal to the square root of, I'm going to take each component function, the 7 squared plus the negative 4 squared. So that gives us 49 plus 16, which gives us square root of 65. So then from our formula, S is going to equal to the integral from 0 to 5, and we're going to have our magnitude of r prime, which we just said was square root of 65, dt. Well, when you got a number and you take an integral of it, you just put a t on it. So this becomes square root of 65 t, 0 to 5. And if we plug in our numbers now, we got s is equal to square root of 65 times 5 minus square root of 65 times 0. And so the 0 times square root of 65 drops away, so our length is 5 square root of 65. And that's our answer. Let's do our next problem. Okay, so we got r is equal to 4t squared I minus t to the third j, 0 to 2. Same instructions. Sketch it and find its arc, find its length over the given interval. And I'll use WinPlot to quickly come up with a sketch. I think I should be able to edit here. So I'll click the edit button. F of t will be what's before our I, which is 4t squared. So I'll do 4t caret 2. And g of t is what's for our j, which is negative t to the third. So negative t caret 3. And that's probably fine for the low t and high t. And let me click OK. It's an interesting graph. So we get that. And we want to find the length of the arc from 0 to 2. Okay. Well, we need r prime. We've already said that before. So for r prime, derivative of 4t squared is 8t I minus, and then derivative of t to the third is 3t squared, and then j. Well, we also need our magnitude of r prime. So that's going to be the square root of 8t squared plus negative 3t squared to the second power. So I square what's before I and square what's before our j, and then we're adding them together underneath the square root. So that gives us 64t squared plus 9t to the fourth. They both have a t squared, so I can factor that out. And that leaves 64 plus 9t squared. And since this is t squared, remember with the square root, we're looking for a pair of somethings. So this comes out as a single t. And we're left with 64 plus 9t squared inside the radical. Okay, so now we're ready to find our integral. So s is going to equal to 0 to 2 of t square root of 64 plus 9t squared dt. Well, this is a u substitution, so we're going to let u equal to what's inside of our radical. So u is equal to 64 plus 9t squared du. 64 drops away. Derivative of 9t squared is 18t, and then dt. Well, we have the t in here, we have the dt, we don't have an 18, so we need to put an 18 in there. I'm going to offset it with a 1 over 18 out in front. And then I have 18t, and I'm going to go ahead and write this in rational exponent form, fractional power form. So square root becomes 64 plus 9t squared to the 1/2 power dt. And I forgot my 0 and 2. Okay, so now we're ready to do our substitution. Now I'm going to put on these that this is t values. So I'll put t is equal to 0 and t is equal to 2. The 64 plus 9t squared gets replaced by u, so we got u to the 1/2. And 18t dt gets replaced by du. Again, this has to match this. And I replace the 64 plus 9t squared right here with the u. Okay. Well, we're going to there we go. Add 1 to our power. 1/2 plus 1 gives us 3/2. And divide by our new power. And that's from t is equal to 0, t is equal to 2. Now we got a single fraction down here in the denominator, so we'll flip it and multiply it times the top. And we can actually take that and put it on the outside of the bracket. So we're going to have s is equal to 1/18 times 2 over 3. See how I flipped it? And this is u to the 3/2. And then t is equal to 0, and t is equal to 2. Now I want to plug my u back in. Well, up here we said u is equal to 64 plus 9t squared. And this simplifies here. So this the 18 and 2 both divisible by 2. So this gives us 1 over 27. And u we said was 64 plus 9t squared raised to the 3/2 power from 0 to 2. Since I put t's back in, I just dropped the t equals part. And now we're ready to plug in our 0 and 2. So let me see. We got s is equal to 1 over 27. And then I got 64 plus 9 times 2 squared raised to the 3/2 power minus 64 plus 9 times 0 squared raised to the 3/2 power. So that's 1 over 27. 2 squared is 4, times 9 is 36, plus 64 is 100. So this is 100 to the 3/2 power. Minus 0 squared is 0, times 9 is 0, plus 64 is 64. So minus 64 to the 3/2 power. Now, whenever you have a number to a fractional power to a rational exponent, you can split them up. You can put the number up on top in the numerator and put it on outside of parentheses. So this becomes 100 to the 1/2 power raised to the 3rd power minus 64 to the 1/2 power raised to the 3rd power. That's one of our properties from intermediate algebra, algebra 2. So I got 1 over 27. And anything to the 1/2 power is a square root, so that becomes a square root of 100 to the 3rd power minus the square root of 64 to the 3rd power. And let me continue up here, burning out of space. So we've got S is equal to 1 over 27. Square root of 100 is 10, so we've got 10 to the 3rd minus the square root of 64 is 8, so 8 to the 3rd. So we've got S is equal to 1 over 27 times 10 to the 3rd is 1,000. And minus 512. 8 to the 3rd. 8 times 8 is 64, times another 8 gives us 512. So then we got 1 over 27 times 488, I think. 0, 1, 0, yeah, that looks right. So S is equal to 488 over 27. This is only divisible by 3, and this isn't divisible by 3, so that's actually our answer. Yeah, let me save that page, and we'll look at the next problem. Okay, so Calc 3 and arc length and curvature, page 01.pdf. Okay. Our third problem. Let's see, R, and that's a vector symbol. I should have said that earlier on in this video, but R is equal to 5ti plus 2tj minus 3tk, 0 to 1. And same instructions. Sketch space curve and find its length over the given interval. So we need R prime. Well, derivative of 5t is 5, so we got 5i plus 2j minus 3k. And then we're going to find the magnitude of that, so we're going to have the square root, and then we'll square what's before I, j, and k, and add them together. So we've got 5 squared plus 2 squared plus negative 3 squared, which gives us 25 plus 4 plus 9, which gives us a square root of 38. So then our arc length, I'm going to go from 0 to 1, and I'm not worrying about graphing these anymore, sketching it. You can use WinPlot to do that. And then I'm going to take the square root of 38, take the integral with respect to t. Well, that becomes, When you got just a number, you put a t with it. So that's square root of 38t, 0 to 1. And if I plug in these numbers, I'm going to have the square root of 38 times 1 minus the square root of 38 times 0, which just gives us s is equal to the square root of 38. So nothing too exciting on that for that one. Let's look at a little harder one now. And I mean, it's not too hard on this one. Actually, that one's not too bad at all either. I like to leave the hard ones for the homework. Let's see. R is equal to 2t. There's a little joke there. 3 cosine t and negative 3 sine t. Actually, arc length, if they're going to work out where you don't have to use technology to do it, you have to design them so they're nice. Because otherwise, you'd come up with integrals you can't find unless you do it numerically. So let's same formula. So we're going to find r prime. So the derivative of that, the derivative of 2t becomes 2. Derivative of cosine is negative sine, so this becomes a negative 3 sine t. And the derivative of sine is cosine, so this is negative 3 cosine t. Okay, so we want to find the magnitude of that. So we're going to have the square root, and we'll square each one of these and add them together. So we've got 2 squared plus negative 3 sine t squared plus negative 3 cosine t squared, which gives us 2 squared is 4 plus negative 3 sine t squared is 9 sine squared t. Negative 3 cosine t squared is 9 cosine squared t. You always like sine and cosine in these problems, but it just comes out super nice. Now these both have a 9 in common, so I'll factor that out, and that leaves us sine squared t plus cosine squared t, which you remember from trig is equal to 1. So this is 4 plus 9 times 1, which gives us a square root of 13. Okay, so now we can find our arc length. Remember, our formula is we go from 0 to pi over 2, and then you put your magnitude of r prime here. So we put square root of 13 here, dt, and the integral of square root of 13 becomes square root of 13t from 0 to pi over 2. Now if I plug these in, I get s is equal to square root of 13 times pi over 2 minus the square root of 13 times 0, which then just gives us pi square root of 13 over 2 for our arc length. And that's our answer. So let me save that. There we go. And let's look at our next formula. Now this gives us a formula for curvature. How curved is it at a particular point? Is it pretty straight? Is it really curved? And so forth. This is used in designing. You could use it to help design roads, because you don't want your a curve to have too much curvature. Otherwise, your cars might go flying off. So you want to have a gentle curve. So this allows you to come up with some kind of measure. Now, we're not analyzing what does k mean in these problems. We're just showing how to find it here. When you get into your application areas, that's where you'll study, what should K be for whatever you're looking at. Now, if C is a smooth curve given by R, and that should have been capital R or uppercase here, that's a vector. Screwed that one up. Then the curvature K of C at T is given by this formula. K is equal to the magnitude of T prime over the magnitude of R prime. Or, you may find it easier to use this formula, because T prime is kind of hard to find sometimes. And this second formula really only works if you have 3 dimensions. But you take the cross product of R prime and R double prime and take the magnitude of it over the magnitude of R prime to the 3rd power. Okay, so let's look at our first problem here. We've got R is equal to 5t I plus 3tj, and to get at t is equal to 1. And instructions say find the curvature K of the plane curve at the given value of the parameter. Well, we need R prime, but we're going to use R prime to find t, so let's go ahead and find R prime first. Derivative of this gives us 5i plus 3j. And we need the magnitude of R prime. So we're going to take each one of these before I and j, square them, and put them underneath the square root and add them together. So we've got 5 squared plus 3 squared, which gives us 25 plus 9, which gives us the square root of 34. Now, we need to find t, our unit tangent vector. That's going to be equal to R prime over the magnitude of R prime. Well, R prime we said was 5i plus 3j, and the magnitude of it was the square root of 34. Now, for this formula we need t prime. Well, if I take the derivative of this, these are all numbers. 5 over square root of 34 and 3 over square root of 34. So that's going to give us the 0 vector. And if I were to find, well, actually, before I do that, at this point, since we're working with something actually in our formula, this is where you can plug in your t equals 1. But if I plug in t is equal to 1, what I'm going to find is it's still just the 0 vector, because there is no t's there. If I find the magnitude of t prime at 1, well, assuming that we have 2 dimensions like we have up here, what's before our I is 0, so we've got 0 squared plus 0 squared, which just gives us 0. And that's what goes in our top of our formula. Now we need to find R prime at 1. Well, R prime was up here, which means that R prime of 1, there is no t to plug into, is there? So this is just 5i plus 3j. And if I find the magnitude of that, that's going to give us the same as what we got right here. So square root of 34. So the magnitude of R prime of 1 is going to equal to square root of 34. So then what we're trying to find, a curvature, is going to equal to the magnitude of t prime at 1 over the magnitude of R prime at 1. Well, we said this is 0 over square root of 34, which gives us 0. And that's our curvature. You're sitting there, well, that's strange. You know, why would you have 0? Well, think what this is. If I set what's before I equal to x, so we have x is equal to 5t, and if I set what's before our j equal to y, we have y is equal to 3t. If I solve one of these for t, so this becomes x over 5 is equal to t, and then plug it into the other one, I'm going to get y is equal to 3 times x over 5. And so we get y is equal to 3/5 x. Think what this graph is. This is a line. It doesn't have any curvature, does it? It's straight. So coming up with k is equal to 0 makes perfect sense in this one. Now our next problem is a little bit more challenging than that. I think this is the hardest one in this section that I'm showing. So let me save this and start a new page so I'll have plenty of room. There we go. And start a new page. And of course, time for my tablet to blow up. So let me bring up a new one. Okay. I think this was number 6. Yeah. I didn't want to do just all trivial problems, so I thought I'd do one a little bit more challenging on this. So we got t squared I plus 5t j. And t is equal to 1. Now, for our formula, and the instructions are to find the curvature. So, yeah, find the curvature. If we come up here to our formula, we need r prime, we need t prime. Now, after we find r prime, we find t prime, that's when you can plug in t equals 1. Up to that point, you do not want to plug it in, because you're just going to get a lot of 0 vectors, and your results will be garbage. Okay, so we need to find r prime. Well, the derivative of t squared is 2t I plus derivative of 5t is 5j. Now our formula is not just r prime, but it's the magnitude of that. So the magnitude of r prime t is going to equal to the square root, and I'll take each one of these component functions and square them. So I got 2t squared plus 5 squared, which gives us square root of 4t squared plus 25. Okay, now that's out of our formula, isn't it? The magnitude of r prime. So we can over here plug in t is equal to 1 there, and that'll give us half of our formula. So I got the magnitude of r prime of 1. That's going to equal to the square root of 4t squared. So 4 times 1 squared plus 25, which gives us the square root. 1 squared is 1 times 4 is 4 plus 25 is square root of 29. Okay, so that's the bottom part of our formula. We still need to get the t prime. So let's continue with this. We first need to find t. Well, t is going to equal to r prime divided by the magnitude of r prime. Well, r prime was 2ti plus 5j over the magnitude of r prime is the square root of 4t squared plus 25. Excuse me. Which gives us 2t over square root of 4t squared plus 25 I plus 5 over the square root of 4t squared plus 25j. And I'm going to rewrite this. This is 2t times 4t squared plus 25 to the negative 1/2 I plus 5 times 4t squared plus 25 to the negative 1/2 j. Well, where do these negative 1/2s come from? Well, the square root of anything is the 1/2 power. So this denominator is 4t squared plus 25 to the 1/2 power. And I take it up on top and it becomes a negative 1/2. I like the product rule, personally. And I did the same thing here. This is 4t squared plus 25 to the 1/2 power. I took it up to the top, and it became a negative 1/2. Now, for a derivative, this is going to be p, and this is going to be q. So P prime will be 2. Q prime. This is the chain rule. We got parentheses to a power. Take power, put it out in front. What's inside the parentheses remains as is. Lower your power by 1. Negative 1/2 minus 1 gives us negative 3/2 times the derivative of what's inside the parentheses, which would be 8t. Well, 1/2 times 8t gives us 4t with a negative. So we got up on top, we got negative 4t. And I'll take this this parentheses to a negative power down to the denominator. I'll learn to speak someday. 4t squared plus 25 to the positive 3/2. Okay, so for a formula, we're going to have p prime q plus p q prime, the product rule. And we're now ready to find our derivative. So t prime is going to be equal to p prime, which was 2, times q, which is this. So we got 4t squared plus 25 to the negative 1/2 plus p, which was 2t, times q prime, which is all of this. So we got negative 4t over 4t squared plus 25 to the 3/2 power. I. Now the derivative of the j portion here, the y of t, this 4t squared plus 25 to the negative 1/2, well, that's the same as my q, isn't it? So we're going to have q prime, but we have a 5 in front of it. So we're going to have 5 times this. So we'll have 5 times negative 4t over 4t squared plus 25 to the positive 3/2 j. Now I could go through exercises simplifying this and getting common denominator and blah blah blah. And I'm going to do a little bit of simplifying. This right here becomes 2 over 4t squared plus 25 to the positive 1/2. I took that negative 1/2 back downstairs. Minus 2t times 4t gives us 8t squared over 4t squared plus 25 to the positive 3/2 I. And then this is plus 5 times negative 4t is negative 20t over 4t squared plus 25 to the 3/2 power j. And actually, let me do a little bit of simplifying just for fun. Got to have a little bit of fun in life, right? Now, I need to get a common denominator. And see how this is 4t squared plus 25, and this is 4t squared plus 25? When they're the same, then you always go with your larger exponent, which is 3/2. And I have to multiply this this here by 4t squared plus 25 to the first power. Because if they're the same and you multiply them together, you add the exponents. So we have to multiply the top part by that also. So we're going to have 2 times 4t squared plus 25 to the first power, and we'll multiply the bottom part by that. So 4t squared plus 25 to the 1/2 power times 4t squared plus 25 to the first power. Minus, and this part remains the same. So we got 4t squared plus 25 to the 3/2 I plus negative 20t over 4t squared plus 25 to the 3/2 j. Okay, so on our first part here, we're going to have t prime of t, and I'm going to multiply this 2 through, so 2 times 4t squared is 8t squared. 2 times 25 is 50. And down below here, since these are the same, you add the exponents. 1/2 plus 1 gives us 3/2. So this becomes 4t squared plus 25 to the 3/2 minus 8t squared over 4t squared plus 25 to the 3/2 I plus negative 20t over 4t squared plus 25 to the positive 3/2 j. I'll have to find a piece of paper here in a minute and jot this down because I don't got room to finish the problem here. Okay. These have the same denominator, so I'll combine together the top parts. 8t squared minus 8t squared drops away, so we're going to end up with 50 over 4t squared plus 25 to the 3/2 power I. That's not very legible, is it? That should be a 3. There we go. And then plus negative 20t over 4t squared plus 25 to the 3/2 power j. And let me get a piece of paper and write this down. And so t prime. Well, pen. Where's my pens? Oh, there it is. T is equal to 50 over 4t squared plus 25 to the 3/2 power I plus negative 20t over 4t squared plus 25 to the 3/2 j. And let me just double check something here real quick before I wipe out that that page. 3/2 plus 20, 29 to the 3/2. Okay, I think that looks okay. Hopefully. And then up here we said that r prime of 1, magnitude of it, is equal to square root of 29. I'd say I hope that looks okay because after I get rid of this page I can't change it. Now I could change it, but I think everything's correct. So let me save it. All of you are watching me, and you're bound to point out my error if I made one, right? So we'll go on that assumption. I hope I get everything written down I need. Okay. So 6 continued. Okay, remember our original is t is equal to 1. And we just found that that t prime is equal to 50 over 4t squared plus 25 to the 3/2 plus, that's I, plus negative 20t over 4t squared plus 25 to the 3/2 j. Now I said we didn't need to actually simplify it because we're going to plug in, at this point we got our formula, don't we? We needed t prime, we came up with t prime. So I could have plugged in the little t equal to 1 and simplified it without simplifying first. But I just wanted to show the steps. But that's what we're going to do now. We're going to plug in 1 for little t. So that gives us 50 over 4 times 1 squared plus 25 to the 3/2 power I plus negative 20 times 1 over 4 times 1 squared plus 25 to the 3/2 power j. So this gives us 50 over 1 squared is 1 times 4 is 4 plus 25 is 29. So we've got 29 to the 3/2 I plus negative 20 over 29 to the 3/2 j. Okay, from our formula we need the magnitude of that now. So let's find that. So the magnitude of t prime of 1 is going to equal to the square root of each one of these squared. So I got 50 over 29 to the 3/2 squared plus negative 20 over 29 to the 3/2 squared. Now we can do a little bit of simplifying. I can split this up. I can put a square around the top. So this is 50 squared over 29 to the 3/2 squared plus negative 20 squared over 29 to the 3/2 squared. Now since they have the same denominator, I can merge them into a single fraction. So we got the square root of 50 squared plus negative 20 squared over 29 to the 3/2 power squared. And we got a property from intermediate algebra says if you have a fraction inside of a square root, you can put a square root on top, square root on the bottom. So we're going to have square root of 50 squared plus negative 20 squared. And then we'll have the square root of 29 to the 3/2 power squared. So up on top, we got 50 squared, which is 2,500, plus negative 20 squared, which is 400. On the bottom, when your index matches the power here, they cancel each other out. So we're left with 29 to the 3/2 power. Well, up on top, that gives us the square root of 2,900 when we add those together. This down here, I could rewrite that as 29 to the let me do that again. This 2 here means square root, and then we got 29 to the 3rd power like that. Well, up on top, that becomes 29 times 100. Down below here, our square root, we're looking for a pair of something, so we can bring a pair of 29s out as a single 29, and we're left with 129 inside. And up on top here, this 100 can come out as a 10. So we're going to get t prime, or wait a minute, this is the magnitude of t prime at 1. Excuse me, is equal to 10 square root of 29 over 29 square root of 29. And the square root of 29's cancel, and we get 10 over 29. Okay, so now we have that, and we have our previous piece. Let me double check that's actually the magnitude we were finding. Yeah, it was. Okay. So our curvature now. Curvature is equal to the magnitude of t prime at 1 over the magnitude of r prime at 1. Well, t prime was the 10 over 29 over this, and I wrote it down from the previous page, remember was the square root of 29. Well, we got a single fraction up here, so you can take this denominator, put it down with this one. So we got 10 over 29 square root of 29. Multiply top and bottom by square root of 29, and we got 10 square root of 29 over 29 squared, whatever that gives you. I won't actually simplify that further, but if you're curious, just plug 29 squared in your calculator and I'll give it to you. And that's our curvature for that one. Kind of an ugly problem. That was like 2 pages worth. So let me save that. So you see they're not all as simple as those first ones I showed. I was just generally introducing the concept there, and that gets into a nasty one there. Okay, so I'll just save that. And let's see, which one was that? That was that one. It looked so simple to begin with, didn't it? So let's take a look at this one. A lot of times we don't like sine and cosine, but they work out very nice in a lot of these problems. They drop away. And this one is pretty easy. Okay, so in this one, same instructions. We want to find the curvature. So we've got r is equal to 3i plus 4 cosine t j plus 4 sine t k, and t is equal to pi. Okay, so let's refresh ourselves on our formula. I'm going to do this two different ways. I did it two different ways in class. I'll do this first formula, and then I'll do this second one. Well, I need r prime. The derivative of 3 is 0, so that drops away. Derivative of cosine is negative sine, so this becomes negative 4 sine t j. Derivative of sine is cosine, so this becomes 4 cosine t k. Now, we also need our magnitude of r prime, which will be the square root, and I'll take what's before our j and what's before our k and square them and add them together. So we've got negative 4 sine t squared plus 4 cosine t squared, which gives us 16 sine squared t plus 16 cosine squared t. Now they both have a 16, so I can factor that out. And when I do that, that gives me sine squared plus cosine squared, which is equal to 1. So this is a square root of 16 times 1, which just gives us 4. And that's a t right there. Okay. Well, we need to find... actually, that's our bottom part, isn't it? We got the magnitude of r prime. Now, there is no t to plug it into, but if I were to do it, this right here, the magnitude of r prime of pi, since there is no t, then it's just 4. So that's going to be our bottom part of our formula. This will be 4. So let's go on to find t. So t is equal to r prime of t over the magnitude of r prime of t. Well, r prime was this, so we got negative 4 sine t j plus 4 cosine t k all over the magnitude of r prime of t, we said was 4. So if I divide this 4 by 4, I get a negative sine t j. And this one, 4 divided by 4 is 1, so that drops away. And we got plus cosine t k. So now let's find t prime. So t prime, we'll take derivative of this right here. Derivative of sine is cosine, so this becomes negative cosine t j. And derivative of cosine is negative sine, so that's minus sine t k. Well, t prime is in our formula, so we can actually plug in our pi now. So we got t prime of pi is going to equal to negative cosine pi j minus sine pi k. If we look at our unit circle, here we are over at pi, which is right here. This is the point negative 1, 0. So cosine of pi, cosine is the x part on our unit circle, so it's negative 1. So this becomes a negative 1 j. And sine is our y part, which is 0, so that drops away. So then we just get j. And let me scratch my eye here. And what we really need is we need the magnitude of t prime of pi. So we're going to take the square root, and we'll take whatever's before j, which is 1, and we'll square it, which just gives us 1. Okay, so now we have all the pieces we need. So our curvature is going to be equal to the magnitude of t prime of pi over the magnitude of r prime of pi. Well, the magnitude of t prime of pi is 1, and r prime magnitude we said was 4. So we get our curvature is equal to 1/4. And that's our first way of doing that problem. So let me save that. There we go. And let's work this problem again using the other formula. And let me... Okay. So this is, which problem is this? I guess this one, number 7. So we got r is equal to 3i plus 4 cosine tj plus 4 sine tk. And got t is equal to pi. Okay, let's look at our other formula. Which one's easier to use? That probably depends upon the problem. T prime is sometimes kind of hard to find. So you might find it easier to find the first derivative and second derivative than find the cross product. So anyway, this tells us we need to find our first derivative and our second derivative. So r prime, derivative of 3i, that drops away. This becomes, the derivative of cosine is negative sine, so this is negative 4 sine t j. And derivative of sine is cosine, so this is 4 cosine t k. Now we also need our second derivative. So the derivative of this, well, the derivative of sine is cosine, so this is negative 4 cosine t j. Derivative of cosine is negative sine, so this becomes negative 4 sine t k. And now we have everything in our formula, so we can plug in the t equals pi. So we're going to have r prime of pi. Plug it in here. That gives us negative 4 sine pi j plus 4 cosine pi k. Now sine of pi is 0, so that drops away. And cosine of pi is negative 1, so this gives us negative 4k. And for our second derivative, we'll plug in pi for t. So this becomes negative 4 cosine pi j minus 4 sine pi k. Sine of pi is 0, so that drops away. Cosine of pi, we said was negative 1. So negative 4 times negative 1 is 4, so this is equal to 4j. Now in class, I didn't actually plug in these values, so this should be interesting. Now this implies we need to find a cross product. I'm hoping you can actually do this, but we'll see. So we've got the cross product of these, which we're going to have our I, J, K across the top. And for R prime, we just had a K, so this is 0, 0, negative 4. And for our second, R double prime, we had 0, 4, 0. Okay, the only one that actually is meaningful, assuming I didn't mess up my signs here, is the I. Because remember, the cross product, you cross out the row and column it's in, and we multiply it times the determinant of what's not crossed out. Well, if I look at J and K, if I cross out the row and column it's in for J and K, I'm going to be left with these zeros here, which causes it to be equal to 0. So we got our I, and again you cross out the row and column it's in, and you multiply that times the determinant of this right here, what's left. Now again what I'm doing is I'm crossing that out, and then the determinant of that. Well, first you do 0 times 0, which is 0, minus 4 times negative 4 is negative 16, so that becomes a positive 16i. Okay, well these symbols are on here. It means I need to find the magnitude of that. So the magnitude of r prime of pi, with, well, in the cross product of the second derivative, is going to equal to the magnitude of 16i, which is the square root of 16 squared, which gives us 16. So far, okay. Now, what's down below here? We need to find the magnitude of r prime. Well, r prime was right here. So the magnitude of r prime of pi is going to equal the square root of negative 4 squared, which is square root of 16, which gives us 4. Okay, so then our formula says curvature is equal to the magnitude of r, the cross product of r prime and r double prime, over the magnitude of r prime of pi raised to the third power. Top part of 16, this is 4 to the third, which gives us 16 over 4 times 4 times 4. 4 times 4 is 16, so that gives us 1/4, which is what we did before. And that's a little bit easier than what I did in class. Not much, maybe a couple steps by plugging in the numbers early on. Save that. And then we'll look at our last formula and last problem. Okay. Excuse me. Time for my tablet to blow up. Okay. Now this is how to find a curvature in rectangular coordinates. If C is the graph of a twice differentiable function given by y is equal to f of x, then the curvature k at the point xy is given by this formula. Well, let's write down this and then I'll flip back to that. We got r is equal to 4ti plus t squared j, and 4, 1. Okay. Now this wouldn't be that easy. Remember when we found a curvature before? This was a nightmare. This is like a two-page problem. Before we were given t equals a value, like t equals 1. Well, if you're not given the point, you could always plug in your t value. Like if I plugged in t equals 1 here, we get 4 times 1, which is 4. And if I plug in t equals 1 here, I get 1 squared, which is 1. So you can get your point that way. Because again, this is your x and this is your y. What we're going to do is we're going to switch this to rectangular. And sometimes by switching it to rectangular, you're going to find it a lot easier to find a curvature. Okay, so we said x is equal to 4t and y is equal to t squared. We want to solve this for t, so I divide both sides by 4. So we get t is equal to x over 4. Well, then we want to plug that back into our other equation. So we just said t was x over 4. So we'll have x over 4 squared, which gives us y is equal to x squared over 16, which is y is equal to 1/16 x squared. Okay, now what do we need for our formula? We need y prime and y double prime. How easy is it to find the derivative of this? This is a piece of cake. Watch me screw it up. Take your power, put it up in front. So we've got 2/16 x, which is 1/8 x. And our second derivative, the derivative of 1/8 x, is 1/8. Now specifically, though it doesn't say it here, what we're wanting to do is when we find y prime is equal to 1/8 x, and y double prime is equal to 1/8, we want to plug the x part of our point in for the x. So then y prime will be equal to 1/8 times 4. So y prime is going to equal to 1/2. Now there is no x here, so this is just y double prime is equal to 1/8. And now we're ready to plug it into our formula. So our curvature is going to equal to the absolute value of second derivative of y over 1 plus y prime squared, all of that raised to the 3/2 power. Okay. So we got absolute value of 1/8 over, let's see, 1 plus y prime is 1/2 squared raised to the 3/2 power. Excuse me. Absolute value of 1/8 is 1/8. 1/2 squared is 1/4 plus 1 is 5/4. So this becomes 5/4 to the 3/2, which is equal to 1/8 over, and I can split this up, so I can write this as 5/4 to the 1/2 power raised to the 3rd power. You can always take the number in your numerator, put it outside of parentheses or brackets, which gives us 1/8 over square root of 5/4 to the 3rd power. And we're going to split that up. Put a square root around top, square root around the bottom. So this becomes square root of 5 over square root of 4 to the 3rd power. So we got 1/8 over square root of 5 to the 3rd power over the square root of 4 is 2, so this becomes 2 to the 3rd, which gives us 1/8 over, when you take this to the 3rd power, that gives us 5 square root of 5. Square root of 5 times square root of 5 is 5 times another square root of 5 is this, over 2 to the 3rd is 8. Since I have a single fraction over a single fraction, both of them have 8 as a denominator, those drop away. So we got 1 over 5 square root of 5. Multiply top and bottom by the square root of 5, and we get square root of 5 over 25. Now, this was much easier to work with this than would be to go through and find our t prime and do it in that manner. So again, this is an alternative way of doing it. And you have to kind of evaluate each problem after you work with a few of them and maybe try it a couple different ways. You're going to see which one's the obvious choice. So let me save that. And that's the last problem. So let's see. Oops. Okay, so I'll stop my recorders. There we go. And then I'll stop my other recorder.